We'll see first example. Example statement is this: count the number of elements in a list within a specified range. Means there is one list containing some numbers. We will enter lower limit and upper limit of a range, and we will find how many number of elements in a list are within that specified range here. Here first we'll create one list having some random values like this. So these are some elements from that list. Then we will enter two values from keyboard, which will be lower and upper limit of this range. This M1, M2 this will be your lower limit and upper limit. Then we'll create one variable C, that is for counting purpose. One loop traverses list, so X will be every individual value of that list. Here we'll check if X is greater than or equal to M1 and X is smaller than or equal to M2. Now, as X is in both conditions, there is one warning regarding with chaining comparison. We'll ignore it. If this condition satisfies, we'll increase the value of C by 1. Finally, C will be our result, so that we will print. In this code, here we are considering lower limit as 30, upper limit as 80, count is 6. So you can see 1, this is 2, this is 3, 4, 5, 6, sorry, 90 is not in that range, 80, so 6. Your answer. This is very simple code. Next example is check whether a list contains a sublist. Means there will be two lists, suppose say L and S, and we want to check whether S is a sublist of list. Means we need to check whether all the elements of second list are available in first list with same sequence here. Here how we can do this program. This is our first list, suppose say L as it is, and then we are going with second list S. We'll create one sublist over here. Right now we are creating all these lists in static in our programs, but you can take it from keyboard also. Here we are entering numbers of second list. So now in our case this is a sublist because 40, 30, 70 is available over here. Okay. So we just want to find out whether S is available in L with same sequence. Whether S is a sublist of L. So this is what we want to find. This is what we want to find, whether S is sublist of L. So here we are creating one flag for that, like say subset. Initial value of flag is false. Sorry, F of false is capital. So this is flag which checks whether S is available in L or not. So we'll go with some different conditions. Right now we know it because we have taken this value statically, but suppose that we are taking this input from keyboard, so we need to check different conditions here. So first condition, what we are checking, whether S is empty. Whether S is empty. If it is, then we are saying subset is equal to true, because in that case this is a subset of L. We are checking whether S is empty. If it is, then subset is equal to true. Then what we are checking next, we can directly compare two lists. Means if suppose S is equal to L, suppose S is equal to L means both lists are same. So in that case also subset is true. Then next condition, what we are checking, length of S is greater than length of L. Means suppose this sublist, what we are saying, is greater than L, which is main list, then obviously it can't be subset. So in that case we are keeping this flag as a false. So these are some primary conditions we check, and now finally we want to check whether all the elements of S exist in L with same sequence. So for that purpose we are writing one loop now. Now see how we are writing this loop. We are going with the range value, and we want to traverse this. See what we want to check. We want to check first element of this list in this list here. So we are traveling this list and we are checking whether S of 0 is available somewhere in L. Okay, so that we can check like this here. Here we are checking if L of I will be act as a index now, because we are starting from 0 and we are going up to the end of this L list. If L of L of I is equal to S of 0. So it means that we find this element in this list here. Now you can say this finding is over here, this finding is over here, but just by finding first element doesn't mean that this list exists in over there. So what we want to do, if first element matches, then we want to check whether these next 2-3 elements are available in this list or not here. For that purpose, here we are creating another variable, say suppose say C, keeping value of 1, because first element we already compared 0th, so we want to check with next element 1. And then we are writing one loop here. That loop should be inside this if. So while C smaller than length of S, means we want to traverse this list now, S list. So that's why we are checking length of S. And also what we want to check, whether this next element is equal to next element of S. So S of N is equal to L of I plus N. The I is already over here and N is traveling from here further. So that's why we are checking it like this. It's not N, sorry, C. So once again, see what we are doing exactly. First we are checking whether subset this small list is empty. Then we are checking whether this list and this list are same. Then we are checking whether this list is smaller than this or not. Now then here in this for loop we are checking whether the first element of this list exists somewhere in L. Then if it exists, then we are checking whether next elements are available in this list or not by using this while. And every time we are increasing this value of C by 1 here. Okay, so it will completely traverse that list now. Now what we have to check, this when this loop will break, when C becomes equal to length here. So if somewhere this C becomes length of S, it means that all elements of this list available in this list here. So in that case, you just make this flag true. So after this while loop, here we are checking if C is equal to length of S, then we are setting subset flag as a true. And finally, after this all if else, what we want to check is flag only. Subset is true, then we need to print here. We'll just print one message that S exists in L. Right now we'll not go in detail of this message. We are printing it like this. Okay, small list exists in large list. So in our case it will be true because this list is in this particular list here. So now we'll do one thing, we'll just add one another element like 67. It should come like false. I haven't written anything to false. We can do here like some message we can print. In this case it will print it. This is a logic which we can find out whether one list exists in another list. Last example, it's a very simple one. Get the largest number from a list. That's very easy one. Suppose this is your list. You can find largest number directly by calling this max function. You can print like this also. Otherwise, we can do one thing. We can sort this list by calling this sort function. And then we'll print last element of this list here. So last element you can check like this, length of L minus 1. That will be your last element, which is once again a max element from that particular list here. So these are the two ways we can find out the maximum number from given list here. So these are some examples we can implement by following idea of functions or methods of list.